My name is Pete Fletcher. I'm a solutions architect or a technical marketing guy at VMware. This is the disclaimer, so we'll spend a couple of minutes on this. Again, Pete Fletcher, Cody Hosterman. Cody works at Pure, brilliant guy. We've been doing a lot of great stuff together with virtual volumes, and if you're in the world of VMware and you've looked at virtual volumes at all, especially on Pure, then you've probably read some of Cody's work. This is the old deck, by the way, so this is going to be real fun.
Earmuffs? Okay, good. Yeah, all right, cool.
This is the old presentation.
Oh, is it? Oh, figures.
Doesn't matter. It's the same content. So the slides are not as pretty, and but the content's good. So, who in here has already tried vVols? Okay, and who in the room has at least heard about it? Yeah, that's what I get. All right, great. So vVols has been around, depending on who you ask, some people will say it's been around since 1974. But the truth is it hasn't officially been around for, what, 2 years now? VMware's been talking about it for a while, unfortunately, way before it was even out. But still we get the same questions from people now that it's even been out for a couple of years. Is what exactly is, I just had a conversation like 20 minutes ago, right before I came here, with somebody saying, tell me, what is vVols and why do I care? Why would I want to use that? I'm fine with VMFS. And so we'll start this conversation by talking about some of the common pain points we hear from VMware environments and why they're excited about moving to virtual volumes. I would say the first is the fact that depending on the size of your organization, your virtual administrator, if he's not the same as the storage administrator, has less visibility into the storage. He doesn't exactly know he gets a LUN. You know, sometimes the storage administrator will give him an Excel spreadsheet with a bunch of IQNs, and he'll try to see which one of these LUNs he's going to use to provision this data store. And so, but there's real no visibility into what that LUN is. You know, what capabilities that LUN has. Is it being backed up? Is it on flash? Is it on spinning disk? What are the characteristics of that LUN? And so there's just no visibility inside of vSphere. Whoops. The second thing is that the capabilities of that LUN are tied to that LUN. So if I've got a data store that's tied to a LUN, every virtual machine that sits in that data store is going to get the exact same class of service. Which is kind of a pain because not every VM is created equally, right? You've got some VMs that need different requirements, whether it's replication, not replication, you want to apply some QoS. So lots of different things that you want to apply to your virtual machine. But if they're all sitting in the same bucket, they're going to get the exact same class of service. And the last thing is it's very vendor specific. So if I have to provision a workload, I got to talk to my storage administrator. Many people involved just to get a virtual machine in production, right? As opposed to just making it simple and one person managing it and and having full visibility. So these are the areas. These are some of the more common pain points that we see that vVols really answers. And how do we do that? Well, first we do that with storage policy-based management. This is a framework we've been using with vSAN for a while, and Virtual Volumes uses it as well. And this is a policy-driven framework that enables the virtual administrator in his environment to, instead of having to guess what the storage is and what the characteristics are, to predefine policies. They can be gold, silver, bronze. They can be application only, operating system only. You decide what those policies look like. But ultimately, you can see specifically what that policy is. Some vendors have RAID type. Some vendors have encryption. So whatever vendor you're using, the policies are going to be different. But you, as the administrator, can create these policies in advance. So when you're provisioning virtual machines, you say, oh, well, this is a SQL server. I need to have the best performance. I need to have, whether it's encrypted or whatever, I'm going to choose this policy. And when you do that, when you're creating your virtual machine, you'll always know that you're provisioning this on a data store that meets the requirements of your policy, because you won't see any data stores available to provision unless they meet the policies that you've created. And they're also at the disk level. So you don't even have to do it at an individual VM level. If you've got multiple disks inside of your virtual machine, maybe your operating system has less requirements in the case of performance than, say, your database. So you could actually apply a different policy for your C drive than, say, your database if you truly wanted to. You don't have to, but you have that granularity. And the other thing that's really important with virtual volumes is the storage that you're doing. You're not pre-allocating space. You're not carving out this LUN up front. You're actually provisioning a virtual machine, and that's when the storage gets consumed. Each individual virtual object, when you create a VM, these are getting created on the spot, so no storage is ever wasted. But more importantly, when you delete it, it goes away. There's no manual process to have to reclaim your storage. You don't have to, you're not going to find a bunch of orphaned objects. You don't have to go and do unmap. It all happens for you inside of a inside of the VASA provider, which we'll talk a little bit more about later. So the high level architecture on this, again, this is VVols, so there is no file system in the middleman, right? These are just native objects that are sitting on the array, and the only way that ESX even knows about them is they get channeled through this thing we call the VASA Provider. The VASA Provider is a piece of software. In the case of Pure, it's actually enabled on the array. You check a box, you have a VASA Provider that's then going to make that connection for you of what these objects are sitting on your storage, and you see them inside of vCenter. So there is no file system to manage. The arrays are logically partitioned into containers. So when you're starting on day 0 with virtual volumes, you create a storage container. Now this storage container can be a portion of the storage that you have on your array, or it can be the entire size of the array. You're not pre-allocating it. You're essentially just saying how much space can my virtual infrastructure consume. And then you also just say in the storage container what capabilities are available. That's day 0. After that, the virtual administrator then takes over and then starts to create those policies that are tied to this storage container. So the storage container, you know, it's not a LUN like in VMFS, because this is just a sort of a logical concept, but that is what gets tied to one-to-one with your data store. The disks that get created on your array when you spin up a virtual machine, these are what we call virtual volumes. Believe it or not, we still have people that the word volumes can be a little confusing, because when you think of a volume, you think you're putting things inside the volume, right? That's not what this is. These are individual disks. So you have a VM that has a C drive. Well, that's going to be a VVol. Then it has an application drive. That's going to be a VVol. When you power on the VM, you're going to get a swap file. That's going to be a swap VVol. So these objects are virtual volumes that are sitting on your array. And all of the I/O that gets addressed, so when you're connecting, we've taken the management control plane outside of the data store level. The VASA provider now is your management control plane. But then the I/O that goes from ESXi to the actual storage is done through this thing we call a protocol endpoint. And so that is what manages the I/O path for you, is this thing we call a protocol endpoint. And what that is specifically, it's technically a LUN with a secondary LUN ID. There's no data on it. But this little LUN is really just there to point to vCenter where what objects on this array belong to the VMs that are being powered on. And then the really beautiful part about this, and we're going to get into details with this, especially with Pure, is that all of your data services, your clones, your snapshots, all of that are completely offloaded to the array. So you're not going to, if you're using VVols, even if you go inside of vCenter and you create a VMware snapshot, that's not going to be a VMFS snapshot. Anybody ever did a VMFS snapshot? Those are great, right? Aren't they awesome? Super fast, never any problems. Right. So with virtual volumes completely offloaded to the array, which is really great. It speeds up your backup times, and it just makes life a lot easier, especially with cloning and all that. And all of this is managed, as I mentioned, through the Storage Policy-Based Management Framework, SPBM. And we'll show you some examples of that. So yeah, big difference here between management. You know, consider VMFS, the way things doing that, carving and spinning up these individual LUNs, that would be, in my opinion, retail, right? You're doing this individually every single time. Whereas with virtual volumes, consider it wholesale. You're doing this upfront one time. You're designing what the capabilities are, what the size of your storage container are, then you're done. You've created your policies. You don't have to do this every time. Virtual administrators don't have to say, oh, I need another LUN. Oh, and this one has to have the exact same performance capabilities as that other LUN. And when humans are involved, it doesn't always work perfectly, right? So matching those up can be tricky. With virtual volumes, you never have to worry about that. You're not individually creating LUNs and assigning characteristics to those LUNs. You've already created your policies, and you just do that one time. So every time you create a VM, you just assign the policies that you've created. So much simpler in terms of management. And so these are what the volumes look like, the VVols, the config, the data, the mem, and the swap. These are just individual virtual volume types, as I mentioned. So a typical virtual machine could have certainly a minimum of 3 VVols. Right? You're going to have your data VVol, which is analogous to your VMDK. You're going to have your config VVol, which has your VMX, your log files, and all that stuff. And then you're going to have a swap file the minute you power on the VM. As you create snapshots for your virtual machines, you're going to have individual mem vVols as well. So those are the different types of virtual volumes that you'll see inside of an environment. So then that begs the question, a lot of people say, oh, well, vVols is great because I don't have to worry about LUN limitations anymore because LUNs are gone, and everybody knows LUNs suck, right? So now we've got these objects, but this brings a slightly different concern, or at least a consideration, is your object count. And so when you're looking at virtual volumes, you just want to make sure that you know on your array, how many virtual machines do I have? How many virtual volumes are they going to have per VM, and do the math and make sure that the array that you choose can support the quantity of objects that you need for your environment.
And the one thing to note too is if you want to intermix VMFS and vVols, you can do that, right? If you want to have your config information and your swap file still on VMFS and then just have your data volumes as vVols, you can do that too, right? There's a lot of flexibility inside of how VMware has built this to allow you to choose exactly where you want these virtual disks and configuration and swap information to be.
Yeah. Yep, that is a beautiful thing. Okay. So this is a completely different deck than what we just went over. So pardon me if I keep looking over here and say, what are we talking about next? Yeah, so the VASA Provider is this piece, as I mentioned, this is the software that's designed by each individual storage vendor. Pure has a fantastic VASA Provider, and Cody's going to go into it. But this is the bread and butter of virtual volumes. This is where everything happens in this piece of software, this VASA Provider. VASA is vSphere APIs for storage awareness. And so traditionally, when you think of VASA awareness, it's just only informing you. But with virtual volumes, it's doing much more than giving you awareness. It's actually giving you the ability to do things like create these virtual volumes, manage your policies, even do a storage vMotion for you on the back end when you actually change a policy. So lots of things happening for you, no manual management anymore. The other question is, depending on, I'm guessing that not everybody here is a Pure customer, although you should be, right, Cody?
I agree.
Cody agrees. But just so you know, there are some vendors out there that have this VASA Provider they don't have it embedded on the array. And so there's been this debate of, should it be on the array, should it not be on the array? VMware doesn't have an official opinion on that because they both work as long as they're certified. The ones that don't have them on the array, they've at least now made it to where the VASA Provider themselves are stateless. So even if you lost the VASA Provider, you're not losing data. You're just essentially losing the ability to manage your virtual machines until that VASA Provider reappears. And even if you completely blow away the VASA Provider, most companies that have them as these vApps essentially have ability to do a recovery and re-index all of the objects that are still sitting natively on your array, and then basically you have a newly populated VASA Provider. So the only thing you lose out on when you're doing it off box, if you will, is a little time to get it back up and running. I personally prefer having it integrated on the array. It makes sense because if your array's missing, that's about the only time your VASA Provider is going to be missing. And if you're missing your array, you probably have bigger things to think about than your VASA Provider.
Stole my joke.
That was your joke? I'm sorry.
Sorry.
You can just make some short jokes.
It's a bad joke anyways.
Yeah. All right, let's see. Where are we here? Okay, so this is Cody.
Yep. So, all right, let's talk a little bit about the FlashArray VASA Provider. So, as Pete mentioned, it is in the array, right? So we have two controllers in the FlashArray. When you upgrade to the Purity 5.0 release that supports vVols, you will get a VASA Provider on each controller automatically. There is no configuration, right? Just once you get there, it's inside of the controllers and ready to go. It is also entirely stateless, right? It is active-active, meaning that either controller, either VASA Provider can take a call from vCenter. Now, vCenter does choose one to use until that goes away, but they are both ready to take calls from your vCenters. The stateless is a very important part, right? And Pete went over some of the details around that. There is no, just like anything in the FlashArray, there really is no state in our controllers. Whether it's your volume configuration, even your fiber channel worldwide names of your front end of the FlashArray is not stored in the controllers, it's not hard-coded in there, right? So if you were to somehow, you had an M50, let's say, which is one of our array models, and you lost both of those controllers somehow, they were destroyed, I don't know, an elephant stepped on them or something. You could take all of your SSDs, throw them in a box, ship them across the country, plug them into an M70, boot it up, it's the same array, right? Same fiber channel addresses, same LUN connections, same host information, same IP addresses. It's an M70 now, but everything is back to where it was, right? The VASA configuration, all that stuff is stored with your data. So if you lose all of your data, who cares about the VASA configuration, right? Like you said.
That's a good joke, Cody.
Thank you. So I thought it was funny. So that's a really important part about it. And I said there are some trade-offs, right? If you have an off-array VOS provider, you could have maybe multiple arrays behind that same VOS provider, having less VOS providers registered. But I think the ability to not have to deal with backup and restore and reconfiguration and limited downtime of losing it I think it's worth that trade-off. Of course, we're always looking for feedback on that. So let's kind of do a quick demo of how to get the VASA set up on the FlashArray. Right? So I have an array. It's upgraded to Purity 5.0. How do I get VMware to start talking to it? Well, let's walk through this here. So I'm logged into my vCenter 6.5. The one note about this is we do support VASA 3. That's in vSphere 6.5 and ESX 6.5. And that includes replication in the vVol spec, which is the VASA 3 spec. So what I'm using here is I'm using our plugin. I can right-click on one of my arrays that I have in my plugin and authenticate. And this is going to add both of the VOS providers from both of my controllers into my vCenter or vCenters if it's like kind of a linked mode setup. Right? So that'll automate that process of getting up and running. This is all the installation configuration you have to do once that array is set up to get your VASA talking to VMware. Right? No deploying, no configuring anything on the array. Just add it into vCenter and you're ready to go. Right? And you can do that for the multiple arrays you might have to add those into your vCenters. So let's talk a little bit about the data plane, because this is a question that comes up a bit. Right? Is how are these vVols physically connected to ESX? Because you're probably aware of some of the limitations of ESX in terms of SCSI devices, right? In 6.0 and earlier, 256 devices and 1,024 logical paths. In 6.5, both of those numbers did double. But thinking about this, right, all the virtual disks you could have, all the virtual volumes, right, config, swap, all this stuff, you could easily outrun that number even with 6.5. Right? It's certainly conceivably possible.
Absolutely.
Right? So how is it done? Well, there's a concept called a protocol endpoint. And this is essentially the only physical device you ever really need to provision, right, to get the physical connectivity up and ready. And this is basically a mount point for your virtual volumes. And it's presented in a traditional way, like iSCSI, Fiber Channel, whatever. When a VM is created, or a new virtual disk that's a vVol is created, that gets automatically created on the array. VASA goes, or ESX talks to the VASA provider on the array, creates the volumes. And then it's like, oh, what host is this VM going to be connected to? Right? And then it'll connect that vVol as a sub-LUN to that protocol endpoint. Right? And the underlying array automatically does that for you. You don't need to go and connect the vVol and there's no rescanning or anything like that. The protocol endpoint is seen once, you rescan it, ESX sees it as a protocol endpoint, right? And the vVols are automatically bound through this. So there's no rescanning to provision new storage, right? Only for that protocol endpoint. And that saves a lot of time often because rescans can sometimes be a problem. And if you're provisioning thousands of vVols, doing thousands of rescans is not something that's going to work out, right? This is why VMware did this differently, and it makes a lot of sense. So essentially your protocol endpoint, you'll see it as LUN 255, conceivably. And then your vVols would be LUN 255:7 or something like that. Right? It's just a sub-LUN to it. So what about performance? Is this going to be a bottleneck to have all these volumes bound through another single physical volume? Well, it could conceivably. Right, depending on how your array does QDEP limits and per volume performance limits, certainly talk to your vendor about what they recommend about protocol endpoints, because I believe there's different recommendations across different arrays. On the FlashArray, we do not have a per volume QDEP limit. So conceivably, if your host can push that workload, a single PE can take the full performance of the FlashArray. Right? And so there are no per vVol QDEP limits either on the array. Right? So the performance limitation then is like, or what can VMware push to a single PE? VMware has changed how they do their QDEP limits. There's a value called PESNRO, protocol endpoints, scheduled number of requests outstanding, that dictates the default QDEP limit for a protocol endpoint. That defaults to 128, and this can go up to 4,096. So if you run that math, like let's say you do the Little's Law thing, and your average latency is a half a millisecond. If you pump up that QDEP limit to 4,096, you could conceivably push 8 million IAPS per host per protocol endpoint. At that point, you need more than one FlashArray, not protocol endpoint. So from a VMware perspective, they've opened up the possibilities, and then from the FlashArray, it's hey, whatever you can push at us.
Whatever you can afford.
Whatever you can afford, yeah. And if you want to create another protocol endpoint on the array, you can. We have CLI, whatever GUI, you can create it. But there's really very little reason to create more than one protocol endpoint. We auto create one PE on the array when you install the vVol purity code, and that's really all you should need for all your hosts on that particular array. If you have another array, then there's going to be another protocol endpoint for that host. So let's look at a quick demo of setting things up. So my VASA provider is registered. I'm going to go to my array, and I have a host group configured. A host group on the FlashArray is a collection of hosts and worldwide names or IQNs or whatever. And I have two VMFS data stores, and that's it. I want to start provisioning my storage container, my vVol data store. So I can use my GUI to provision the protocol endpoint, connect to the host group, rescan it, or I can use our plugin. You choose vVol under the Create Data Store wizard, give it a name, choose the array. It'll look at that host or cluster you're provisioning to. Is there a PE assigned? No. All right, I'll attach it to that host group automatically, rescan it, and then I'll mount that vVol data store. If there's already one, well, it'll move on and just go ahead and mount the data store. And so this will, you can see the PE now is provisioned to this host group. And it's associated with that storage container. And if we jump back over to the FlashArray, we'll see my pure protocol endpoint has been provisioned to that host group. So there's very little reason to really have to do anything on the FlashArray GUI or CLI to get things set up. You can use the plugin really to do pretty much all the configuration work. We want you to stay in VMware's interface. Right? Come back to us if you need to do some trending or analytics or something like that on your storage. So when you create a vVol VM on the FlashArray, the first thing we're going to do is create what they call a volume group. Nothing profound. It's a group of volumes, but it is named according to that virtual machine that you've created. Right? And so when vVols are provisioned to that VM, they're added to that volume group. Now, the volume group is not a unique identifier of that VM. If you delete the volume group, it's not going to break us. We just use it to have a way for you to report on that VM, to manage that VM as an object, right? But all the underlying information, the connections and stuff are not directly related to this volume group. We didn't create a VM object because we wanted other users to be able to use the volume group, right? It makes a lot more sense just create a volume group that doubles as a VM, or if I have a Hyper-V or if I have physical or whatever, they can use volume groups too and report on objects. I've never heard of it. Just some letters I made up. It's the wrong thing to say. So using this object, you can then either report on the VM, volume group, or you can report on the individual vVols if you want to. Another kind of value add that's offered by the FlashArray is when you delete a volume today, or any object really, snapshot, something, it goes into our destroyed objects folder for 24 hours. Right? What happens if you delete a VMDK today? You know, you edit settings, remove, and then delete from disk. How do you get it back if you accidentally deleted the wrong one or someone told you the wrong one? Well, you got to go to your backup, or maybe you have an array-based snapshot, and then you can mount it, resignature it, pull it out, and delete it, and all that kinds of stuff. Right? It's a process, but it's, you know, there's tools to help you, but it's not beautiful. With vVols, now, when you delete a virtual disk, it's just deleting the volume. So it's going to go into our destroyed volumes folder. So you can use our GUI if you want to recover it, or you can use our plugin. You can right-click on a VM. We'll show you any deleted virtual disk, aka vVols, for that virtual machine, and we'll add it right back for you. It's a very similar process for even recovering a virtual machine as well. So let's take a look at this process. So I currently have two vVol. This is our FlashArray tab we added with our plugin on this VM. And we have a couple of vVols provisioned to this virtual machine. So I'm going to delete one of them. Right? And VMware really strives to not change how you manage your VMs or your storage. Right? It's all very similar workflows. Right? So nothing you really need to relearn. Now if we go to the array, we'll see our destroyed volumes folder. And there I have a destroyed data vVol. Now I could recover it here and bring it back and do an imports vVol snapshot SDK call, or I could use the plugin. Right? Click on restore deleted, choose it, adds it right back. Right? Pretty slick process. And of course, these are all just using APIs, right? So if you want to automate this, if you want to build this somewhere else, you can certainly do that. Plugin's not using anything proprietary. And so the crux of storage policy-based management, of course, is creating a policy. Right? You don't have to use storage policy-based management with vVols if you don't want to. You can just create VMs that are vVol-based, right? And that's fine.
Yeah, it'll use a default storage policy if you don't choose one.
Exactly. Or if you want to apply special configuration, replication, snapshotting, whatever, right? You can create policies. When you register the VASA provider with vCenter, that VASA provider will tell vCenter, these are the things I can do. I can replicate, I can snapshot, right? I can do a million types of RAID, whatever. And then when you mount a storage container, that storage container then advertises back to VMware, the array that I represent, these are the things out of that menu I can actually do for you. right? So when you create a storage policy, you can use our capabilities we offer. Some of them, and I'll go into these in more detail after a couple slides here. I just want this VM to always be on a flash array, or God forbid, I don't want it to ever be on a flash array. Right? Or I want it to be snapshotted every 5 minutes. And you can set the policy on the VM layer, like I said, or in the individual virtual volume. So let's talk about snapshots.
Yeah, absolutely. I wanted to add to the point that Cody was talking about earlier, where this is not a different, completely different technology. You know, that they're reusing their terms for groups, but with virtual volumes, it's the same thing. This is not, you know, this still works with Fiber Channel, iSCSI, NFS. There's no new protocol just for virtual volumes. This is just, you know, inside of vSphere, so it still uses, you know, T10 standards. So this is not something that's vVol specific. This is essentially just another way to manage your virtual infrastructure other than VMFS, with the added benefits that we talked about in terms of simplicity, in terms of managing your environment, improved performance. You know, it's just a smarter, simpler, and faster way to do what you're already doing. And on the performance side, I wanted to just sort of do a side-by-side comparison of what it looks like doing a VMware snapshot using VMFS, and then a virtual volume snapshot, which would be offloading to a pure array in this case. So on the left, I've got my VMFS snapshot here, which is currently writable. And then I go ahead and create a snapshot. So what does VMFS do? Well, it creates this redo log, and then vSphere starts pointing to this redo log, this snap VMDK, and starts writing into that. So all my I/O now is going into this redo log. Then I go ahead and create another one, same thing. vSphere points to the secondary snap VMDK, all I/O starts going into that one. And so if I wanted to actually delete these snapshots, anybody delete a snapshot in VMFS before? And yeah, exactly. So it takes a really long time depending on how long it's been there, how much I/O is in there. You know, it certainly hits your performance. So it can be a very time-consuming process, whether you're doing backups or whether you're just manually doing it. You know, we did a session last year at VMworld called Snapshots Suck. And it was great because it was great. The VMware folks approved the session, but they said you have to change the name. We didn't, but but you know, everybody would come up to us afterwards and give us those painful stories of, yeah, we had to write a custom script in our environment not to let the users create snapshots, or it goes out there and scans them and deletes them after 24 hours. And so everybody has been inventing ways to fix this pain point, right? Well, with virtual volumes, the pain point is just non-existent. It's gone. Like, it literally just completely offloads to the array, which means even your backup software. If your backup software is using virtual volumes and it's supporting VADP, the backup, it's just going to say, oh, I need a VMware snapshot. And the VASA provider is going to be involved and say, got that. And I'm going to go ahead and offload that to Pure to create the snapshot for you. And so what that looks like is create a snapshot. You know, basically a little bit of metadata manipulation. I've got an instantaneous snapshot available. Now vSphere is still going to point to that snap VMDK, but this is a read-only snapshot. So what vVols does on the back end is it just swivels or swaps these pointers up to the original vVol. So the vVol is always writable. The snapshot is there available for any restores or whatever, but it's just essentially never in the I/O path, which is the important part, because I/O is always in the same spot. And so I have an instantaneous snapshot, but I also have an instantaneous deletion if I need to. Because when I delete it, it essentially just kills the snapshot, the pointer goes back to the main VMDK, but I didn't have to move or copy any I/O, any data over to the original place because it was there the whole time. So much more efficient way of doing it. And if I wanted to revert to an individual snapshot, same thing. Little data manipulation to the pointers, which essentially creates a backout first, just in case something goes south. But then it goes ahead and basically metadata manipulation makes that main VMDK what the snapshot is, which is the point of reverting to the snapshot, and then vSphere will then point to that main VMDK. So it's a very instantaneous process that significantly will speed up your backups, but also just your day-to-day management of handling snapshots.
So virtual volume snapshots on the array, right? It's pretty much what he mentioned, right? Is standard tools, right? You right-click on your VM, you create a snapshot. You go to PowerCLI, create snapshot. Whatever you use today to create VMware snapshots, same process. But the difference, right, is it creates array-based snapshots for those data vVols. Right? And the nice thing about the FlashArray snapshots, right, is that they're, regardless to the size of the source volume, they're created instantaneously, right? There's no performance impact because they're not like copy on write or redirect on write or anything like that, right? And they're 100% deduped, right? And compressed, right? So they only store the unique and deduped, globally deduped changes from the source volume. And the nice thing about these snapshots is that they're just snapshots, and they're snapshots of NTFS or of XFS or whatever that guest put on them. So if you want to take these snapshots and bring them up somewhere else, you can easily do that, right? Pure vol copy. It's a copy command. Use the GUI, copy that snapshot to another host. We have a plugin as well, features that take any vVol or any vVol snapshot and present it to any other VM instantaneously, right? Create that point in time, create a new one, create the point in time of right now, or choose one of its snapshots, bring it up to another VM. Right? So the plugin will import those to other VMs or also overwrite them if you want to. Right? This is particularly important for dev test scenarios. Right? So the plugin offers this, or once again, REST, PowerShell, Python, vRealize Orchestrator. Right? You can do a lot of stuff to move these snapshots around for dev test or whatever, restore as well. And because volumes on the FlashArray are copied instantly, there's no waiting. Right? We can copy, it's just a metadata copy. Right? So restoring or copying to a new one or creating a new one from that is something you can do instantly. Right? So the nice benefit of what VMware did to leverage array-based snapshots and then adding that in what we do on the FlashArray for snapshots in general.
Yep. And so, as I mentioned earlier, vVol's been around for about 2 years, and I spent a significant time last year on the phone or talking with customers about virtual volumes, how they really love the idea, sounds great, but can I replicate my data? And we would say, not yet, because that's coming in the next version. And that really slowed down our adoption for vVols, because most customers were like, I'm in. As soon as you have the ability to support replication, then we're there. And this also varies by vendor, because we have a lot of vendors that were on the 2.0 certification of VASA that did not have replication, and but they haven't gotten certified for 3.0 yet. So even some companies, and I won't mention any names in that, but there are some companies that are not currently replicating, but they were on the first version, right? And so, but Pure does have replication. That was one of our big 6.5 announces to support array-based replication, which was a big showstopper. And the other version of this presentation that we had actually had a graph showing you some of the adoption rates that we've had. I mean, Nimble just shared with me the other day that they have over 1,000 customers currently using vVols now, and it was really since the array-based replication piece, the ability to replicate, but then also fail over to that replication, do some DR type scenarios, and all of that has come in with 6.5. So if you're on Pure, it's a no-brainer because they're VASA 3.0 certified. If you're looking at another storage vendor, my only suggestion would be to just verify with that vendor that they are 3.0 certified, if in fact you need to have support for array-based replication. vVols does support vSphere replication, so you still have the ability to do some replication. But if you probably have a really shiny, array sitting in your data center, and you've already paid for the licenses to do these types of, efficient replications, you're probably going to want to leverage that. So just be sure to check that before you jump over. So as I was saying, with replication, the way it works is very simple. You've already created your policies, gold, silver, bronze, whatever. And then you spin up a new VM. What you can do, the filter is there, so it's filtering now that this production OS disk, which is my policy name, it found a data store that is compatible, which is this Anaheim vVol, and then incompatible ones as well. So it's only going to let me provision it on this compatible. But then on the bottom here, outside of the gold, silver, bronze, or whatever policy names you chose, I now have this replication option. And so I can choose predefined replications. Maybe I set up some periodic replications for maybe daily, also hourly, depending on my workload. Or if I don't have any replication policy set up and I just want to go automatic, vVols will then actually create on the fly a replication for you, a replication policy for just that individual VM. But if you've pre-configured replication groups, maybe you have a bunch of VMs that need to be in that same replication group, then when you provision your VMs with a certain policy, you assign those replication groups and they all replicate together. So this is all, there are options when it comes to replication. Yes, sir? Okay, so essentially the question was around how vCenter handles the management of this replicated data from one array to the other, and whether or not there's a requirement for 2 VASA providers and how that's handled. So essentially what happens is you've got your one VASA provider, and that has a replication, can see both arrays, does the replication for you. Now when you want to fail over, Currently, in this version, in 6.5 that we have, there is a VASA provider on your other vCenter server, for example. If you're having two separate vCenter servers, that's going to have another VASA provider. So if you replicate over, you could now replicate policies, and there's a way to automate that I could show you a blog post on, but it's not integrated natively inside of vSphere. You would essentially have to one for one have similar policies on both sides, so when you do the failover, it's there. It's a one-time thing. It's not a showstopper. But I can say, I know the product manager's not in here, so I'll say this. I know that it's on the roadmap, and I know that the ability to replicate information between VASA providers is something that we've heard that feedback and are certainly looking into. That's as far as I'll take it, so I can keep my job.
All right, so from a FlashArray perspective, what are some of our capabilities? So there's some core ones, basic ones, right? I want it to be on a FlashArray. Right? I don't care which, just a FlashArray. I want it to be on one of these FlashArrays. I have 4 in Chicago, and I have 4 in New York. I just want this VM to be in Chicago. As long as it's on a Chicago FlashArray, it's compliant with that policy. QoS. Right? Our initial version of QoS is array-wide. So if it's enabled, I want this VM to be on one that has QoS enabled. I want it to not. Right? And I'll go into replication and snapshot capabilities here in a second. But as we add features to the array, we're adding our more granular QoS pretty soon, our active replication, all that kind of stuff. We add more capabilities into your menu that the VASA provider tells back to vCenter. All right, so these are some of the basic ones. Moving into like local snapshots. Now you can right click and create snapshots all you want, or you can have them created by the array via policies. Right? I just want it to be on an array that has a policy. I don't care what, I just want it to have a policy. If that's once every 4 years or once a day, great. I want it to be snapshotted every 5 minutes, every 10 minutes, once an hour, once a day, whatever. I want it to be, those snapshots to be retented for X amount of days. Right? I want this retention policy for it. Right? So the more granular and the more capabilities you include in a policy, the more control and configuration you have. You might say, I don't want it to be snapshotted. Right? So you'd say your local snapshot, I don't want it to ever be snapshotted. Right? And so that would filter it out from putting it into something that has a local snapshot policy. Right? Enabled. Replication. Similar thing. I want it to be replicated, or I don't want it to be replicated. On the FlashArray, we have things called protection groups, and protection groups have protection policies. And there's 2 parts of those policies, a local snapshot protection policy and a replication policy. So maybe I want this VM or this virtual disk to be replicated but not snapshotted. So I would say, oh, yes, replication capable, but local snapshot not. Right? Or the opposite, if you want. Right? The more you put in, the more information, the more specific the request back to the array. Replication interval, right? Every 10 minutes, 20 minutes, hour, whatever. Target sites, or retention as well. Target sites, I want it to be replicated to these 3 sites, to one of these 3 sites, for instance. I have 3 arrays, I just one of them. Or I want it to be replicated to all 3 of those. Or if I have 5 flash arrays that are targets, I want it to be replicated to 4 of those 5. I don't care which. Right? So you can control the concurrency of replication and exactly where it's replicating to via policy inside of vCenter. So let's take a look at how these policies can be created and set up inside of vCenter. So I'm inside of vCenter. I'm going to go to my policies and profiles. Click on my VM storage policies, and there's some default ones. Right? Pete mentioned there's a default vVols one. So I can manually create them if I want to, showing that screen we saw before, or I can right-click on one of my flash arrays and do import protection groups. Our protection groups are policies on that array. I can automatically take all of these policies and convert them into storage policies inside of vCenter. Right? So I'll immediately have the exact policies on that array available for provisioning inside of vCenter. So here I have one with a local snapshot policy of 10 minutes and also a replication schedule of every 5 minutes. Right? That's one of my protection groups. You can see that's listed here. I'll import it in, and if I go back to my storage policies, I'll see that those have been created inside of my vCenter. So this is a way to automate kind of getting up and running with those policies if you want to, but as I said, you can manually go and create them, or you can take these ones and go and edit them and change them and make them more granular, less granular, right? But then if you change them, you may or may not have that policy available on that particular flash array. But it might be relevant to another array in your environment, right? And so here's this policy. It's configured exactly like that protection group. Right, so this makes it a lot simpler to get up and running. Now, once I've created this policy, do I have any storage that can offer this up? Yes, I have one compatible vVol data store that represents an array that will fulfill that policy if I provision a VM to it at that point. Right, so pretty easy to get up and running with vVols on the FlashArray using the plugin, or honestly even just clicking around. It's not going to take that long, but some of these things we built into the plugin to make it easier.
Awesome. So you've built a policy. Your policy has replication in it. You replicate your virtual machines. Everything's good. And all of a sudden you have a disaster. What do? How do you restore that virtual machine? Anybody in here using Site Recovery Manager today? Okay, for Site Recovery Manager, if you're going to use virtual volumes today, it's going to be using vSphere replication. The SRM team has not released support yet for virtual volumes for array-based replication. Works with vSphere replication today, does not work with yet with array-based replication.
Open enhancement requests for VMware, please.
Yes, please. The good news is the majority of customers, the overwhelming majority of VMware customers that are doing disaster recovery actually use automation outside of SRM. They're using some form of automation. Is anybody using any automation in this room for their DR currently? So it's usually the really larger scale environments. But the good news, any PowerCLI users in the room? Oh yeah, I was hoping to see every hand because yeah, PowerCLI is awesome. Anyway, we do have full support with PowerCLI to completely automate your replication policies. So to speak like SRM, you have the ability to discover your replication groups, to do test failovers, to failover, to fail back. All the familiar workflows that SRM has, those common DR workflows, can all be handled using PowerCLI commandlets to completely automate the process for you. So we've got some blogs out on VMware virtual blocks that'll show you some examples. We've got some sample code up on github.vmware.com or vmware.github.com, whatever URL that is. But yeah, so there's some really good sample scripts on doing the failover. But if you're stuck on using SRM, it's going to happen with vSphere replication until we hear new news from the SRM team. Again, call your TAMs immediately.
And also, like you said, there's APIs for all the storage policy-based management, and like vRealize Orchestrator has a SPBM plugin now, and vRealize Automation can leverage that through infrastructure as a service, right? So there's a lot of options around leveraging outside of PowerCLI as well. Yep. So this is a very important part about vVols too. There's a lot of stuff that can help you today with VMFS and VMware with day zero provisioning, right? I want to create this VM on a replicated data store, right? There's stuff there that, oh yeah, it's currently replicated or whatnot, and there's some good ecosystem of products that can help you understand what's happening right now. What if someone goes to your array and makes a change, right? Yeah, you probably have change control, right? And maybe that is vetted, but maybe the VMware administrator or the owner of that VM, they may have no idea that that has changed, even though it's been approved and gone through change control. Right, so what's important about applying these policies is making sure they're configured that way through the lifetime of that VM. Right? And today, there's not a good way of knowing inside of vCenter and having vCenter know and tell you that something's changed. Right? And this is an important part about storage policies, that if someone goes to the array and makes a change that violates that policy, VM will report that. Yes, this VMDK, this vVol, is no longer compliant. This virtual machine is no longer compliant. So then I can go to the array and fix it, or I can rerun it through the provisioning wizard and say, all right, here are your options now. All right, this is how you can fix this compliancy problem. So let's look at a quick demo here. Let's deploy a virtual machine from a template. Once again, same process as with VMFS. All right, no different here. I'll choose it, give it a name, choose my data center, and then of course my cluster. And now let's choose the storage. So first I'm going to choose, instead of just a data store, I'm going to choose a policy. Right? And I have a variety of different policies I can choose from. They've been imported before, as you saw. And it shows my storage container that's valid and the protection groups on the array that satisfy that particular policy. Right? So go ahead and hit next, and we'll provision the virtual machine. So this is going to go to the array. It's going to create the volume group. It's going to create the individual vVols as specified in that template and add them to that volume group. Go ahead and power it on. And that'll, of course, create the swap vVol. Right? If I would power it off, it's going to delete that swap vVol from the array. So let's move forward here. Let's take a look at our policy that we provisioned it to. So I'll go to my storage policies, and under it, and you can actually also see this from the VM pane as well. I can see the virtual machines under that policy or the virtual disk, and they're currently compliant, which is wonderful. What happens if someone goes to the array and screws with my protection groups? Right, so I'm going to go to the protection group that contains that virtual machine or that individual vVol. You can see that right there. I'll just change it. Right? I think it was 10, change it to 11 or something like that, 15. Save it. So now it is replicating or snapshotting every 15 minutes, not 10 like I originally had. VMware now reports that VM and its virtual volumes as non-compliant. I go back to the array and fix it, this is one of the options. It'll be compliant again. Or I could reprovision it through the standard tools, right? Applying a new policy or whatever, or just moving it somewhere else. Right? So this day 2 management of your virtual machines is extremely important, right? Especially as VMware environments is larger and larger and larger, right? To have this feature inside of vVols, I think, is very, very useful.
Yep.
So the last question often people ask is, all right, great, how do I get to vVols? Storage emotion, right? If you want to move this VM, this virtual disk, storage emotion. VMFS to vVols, vVol to VMFS.
There's no vVol migration tool that I need to install?
Nope, not at all, right? Just storage emotion, right? Once again, VMware really strived to make managing, moving everything no different than it was before.
To and from, too.
To and from, exactly. If the VM is on the same array as that vVol data store, it'll use VAIX copy, right? So it'll speed it up a bit. So it'll just, and on the flash array, we're just going to move metadata pointers from that VMFS volume to those individual vVols. If it's on a different array, it's going to use standard read and write. If the source is a vVol and you're doing a deploy from template, for instance, or a clone, it's just a single, essentially, call for each volume, and it's a pure vol copy. So we can copy VMs essentially instantly once the source is now vVol 2, right? Because with xcopy it makes it faster, but they have to send a 1,000 of xcopy commands to describe the VM. With a vVol-based VM, basically 1 command or 2 commands per VM. Right? I did a test a couple months back where I copied 100 500 gig VMs via xcopy. It took 23 minutes, which isn't bad. I did that same test with vVol to vVol, deploy from template. It took 93 seconds, right, with 100 500 gig VMs, right? It's a pretty significant change.
Oh, yeah.
So the last point I want to make is, are vVols special? A large concern that's been around since the very first day I saw a vVol presentation, I think here in Vegas in 2009 or something like that, was, all right, I've already got a little bit of lock-in with VMFS from a data perspective. vVols is a proprietary architecture, right? I'm going to be even more locked in, right? My data is stuck now forever. Right? All this VASA and all this protocol endpoint craziness. In reality, that's not true. vVols unlocks your data, right? There's no more VMFS. There's no VMDK file, right? A vVol is just a sub-LUN, T10 standard, right up the SX. The only way it's special is how it's seen as a LUN to that host. So you can take that same volume and present it to a physical server at the same time if you want, if the host can do the control of the file system. Or you can take take a right-click on your VM, create a snapshot, take that snapshot, present it to a physical server or another VM or an older VMware environment as an RDM if you want to. Right? We've announced some features that are coming out pretty soon too called Cloud Snap, where we can take snapshots and send them to S3, send them to NFS. Right? So you could bring it up, that VMware snapshot, bring it up in S3 as an EBS volume or something like that. Right? There's a lot of cool stuff. I'm really excited to see what customers do with this kind of openness that vVols provides and what we do with the FlashArray to make it simple to move data in and out of the cloud. Right? I think this is a perfect segue into the whole VMware and AWS stuff. Right? There's a lot of cool stuff I think will be coming, right? From VMware and from, of course, Pure as well. And so, as I said, a lot of interesting use cases this opens up. If you have an RDM today, how do you make it a vVol? Well, you remove it as an RDM, connect it back up as a sub-LUN. Right? There's a VMware API to do that, or we have some options as well. So there's no migration. And once it's a vVol, it's in the virtual SCSI stack. So you can clone, deploy from template, all kinds of cool stuff, right? Without losing that file system problem. In one of our beta customers earlier this year, what they were doing is they had a physical production Oracle environment, and they had their dev test on VMware. And they had to use RDMs before because it's the only way they could move the data in and out easily. In the beta program, they just take the snapshots of their physical environment, present them as vVols to their dev test, right? So they can have all the benefits of the VMware storage stack, right? And every time they refresh it, what they do, just, pure vol copy from that snapshot to that target vVol, right? Giving the new point in time of that database. A lot of cool use cases around this. And that does it.
Yeah, and so I think the most important thing I want you guys to leave here with today is that when you're filling out your surveys, Cody was the one that made that really loud noise on the microphones. It was Cody, not Pete. But please fill out a survey. We're going to stick around for questions, so don't leave if you don't want to. But we definitely want to stick around for some questions. But the quick pitch for me that I'd like to share with you guys, if you take anything away from this, is that vVols really is truly simpler, smarter, faster. It's simpler in the sense that when you're managing an organization, you don't have to have LUN sprawl. You don't worry about LUN limitations. You basically can have essentially one data store and have all the same granular service to manage all your different classes of service, but it's just a simpler way to do business, wholesale versus retail. It's much smarter because now I have full visibility in there, as we talked about, and you can manage everything through your policy-based management, so it's just a much smarter way of managing everything. And it's certainly faster in the sense of the way it offloads to the array for the clones, for the snapshots, and for backups. And so simpler, smarter, faster is essentially, when people ask me why would I consider vVols, that's the easiest way that I can think to say it. So we're going to stick around for questions, and please fill out the surveys, and thanks for coming.
Thank you.